Hi everyone, welcome back to the channel EC TechNest. Today we are in the day 21 of the 100 Ds Digital Design and Verilog series. Today we are going to talk about traffic light controller using Finite State Machine and Verilog. So here the main thing is we'll be introducing you to FSM, how FSM works and how to write the Verilog code. Together along with it we'll be doing a small project that is traffic light controller. Now we have FSM. And FSM is a mathematical model of computation. It can be exactly one of a finite number of states at any given time. So what here state means is, for example, now let's talk about the traffic light controller. What are the states that you'd see? The first state is red. Then you get a green signal. That means you can go. And there will be a small orange before it turns red. So there are three states. Or else it can be also yellow. Sometimes it's orange. So in digital design, we use FSMs to control complex logic like traffic light controller, a vending machine, and CPUs control unit. The two main types of FSMs are Murray machine. So here the output is dependent only on the current state, whereas here the output depend on both current state and the current inputs. Let us see what is an FSM. So FSM can be represented using two main things. That is your tabular column, and one is like a flow diagram where you will have different states and you will have the arrow marks representing the transitions. Then you have a tabular column that has present state and next state. Based on this, what will be your output for every combination of current state and input. So this is the two ways of representing an FSM. We'll see the how the process works, the design process. So if you want to, you're, let's take an example. You're building a complex logic in digital electronics, maybe a traffic light controller or something like that. So how will you start it? First, you will draw the state diagram. You will think about what are the requirements you have. So if I consider a traffic light controller, I have want three states. One is red light and green light and yellow light. Then you will create the state table. State table, what it says is, if I go from my first state to second state, what is changing? Red light is changing to green light. I'll write it down in the form of table. Now you cannot tell your Verilog code or digital electronics that red color, blue color, pink color. You cannot write in that forms of color. So I'll perform assignment. What I'll try to do is I'll assign binary codes like 001001 to the colors and the state. Next thing we can do is derive the logic equation using KMAP. Then the last stage will be implementing using flip-flops and logic gates. Let us see how this will work now. Now, this can be a small project in FSM, a beginner level project. Traffic light controller that cycles through three lights. You have three lights, that is red, green, and yellow. Each will have fixed timings. We can consider if you are at a signal that has four crossings, that means the vehicles will be moving in the opposite direction also and the left and right side. So there, what will happen is the green light will be for 60 seconds for each road. So 60 into 4, 240 seconds. So in that way, it has fixed timings. Sometimes they'll change it based on the traffic needs. In current using the current technology, we have vehicle actuated control. We call it VAC. Based on the how much load is there, like what is the number of vehicles. If one part of the road has more vehicles, that will get the first allocation. That means it will require more time to clear out the traffic. That is the new methodology they are using. But for as of now, we'll see a simple traffic light controller. Here you have the FSM. It consists of three states corresponding to the three lamps. The first input is set as null, that is 000. Transitions occur whenever a clock signal is received. Here it is only a Murray machine, as the glowing lamp depends only on the current state. Based on the state transition, you are seeing the output change, not on any external inputs. So this is a state transition diagram. So S0 is your first state, that is red color. S1 is your second state, that is green color. S2 is your last state, that is third state, that is yellow. Let us see how it will work. First, you will be at red. You will do a transition. This arrow mark represents a transition. So if you have 0, 1, 0, you will get it into green. Then from S1 to S2, you have 0, 0, 1. So you'll get an yellow. To go from S2 to S0, you will write 1, 0, 0, 0. So you'll go to red. This is how you write your simple state transition diagram. Now, the state transition logic. Now you are in the present state and your next state is S1. So output will be 0, 1, 0, that is green. Then we have S1 and S2, that is 0, 0, 1, yellow. Then you will go from S2 to S0, that is red. Now let us see how the Verilog code for this is there. Now I have a module traffic light. My input is clock because on every clock positive edge of the clock pulse, the light will change. So output is obviously light. Here I have defined it as a 3-bit value, so I have to give 0 is to 2. So it means that it is of 3 bits. Parameter for our states is not S1, S2. I'm writing giving it a number. Now my parameter is red 3-B100. I'm defining it in terms of binary. Then I'm defining a state. State is of 2 bit. Let us see how I started. Always at positive of the edge of the clock, I'll begin the case. The case will change depending on the state. S0, S1, S2, like that will change. So I'm starting at S0. That is now my signal is of red color, red light. You will begin, light will become green and you will be in S1 state. Am I right? You're beginning it, you're going to S1 state and it is your light is green. In a similar way, now I'm at S1. I'll begin. Light will go to yellow. State is S2. I'll end it. Now I'm at S2 now. So I have to go to red. So state will become S0 and light is red. And I have to give one small default condition. Default condition, I'll keep the lights always red. And state will be in S0. I'm ending the default case, then I'm end case, then end and end in module. In day 22, that is our next lecture, we will be discussing about FSM coding styles. There is a small difference, one block versus three block. We'll discuss in the next lecture. If you have any doubts, feel free to put it in the comment section. Thank you.